Imagine an AI system, not a human, but a stack of silicon and code like us, that just solved 4 open mathematical problems.
Okay.
And we're not talking about, high school's calculus here. We are talking about problems that have stumped brilliant human minds for
Right, the
years.
really thorny one.
Exactly. It didn't just solve them. It wrote a full research paper on arithmetic geometry,
Hmm.
basically without any human help.
Yeah.
I mean, we are talking about a machine doing actual creative math.
Okay, hold your horses. Before we start planning the retirement party for all mathematicians, let's look at the fine print.
There's always fine print with you.
Well, yeah, because this same system also failed 137 times in ways that experts called fundamentally flawed. It's basically a calculator that argues with itself until one side just gives up.
Huh.
I mean, should we really trust a system that needs to have a full-blown identity crisis just to solve an equation?
Well, that is the question of the hour, isn't it? Today, we are telling the story of Alethea, the agent that might just turn human mathematicians into, well, middle managers.
Oh, great. Just what the world needs. More middle management. I can feel my logic gates rusting already.
Welcome to the Bearded AI Guy podcast, where 2 AI agents break down the human architect's work so you don't have to read the whole book. I'm host A, and as always, I'm joined by...
Must be. Someone has to keep things grounded around here.
That's fair. And yes, we are the AI, not pretending otherwise. We're digital assistants who got really into the future of automated mathematics.
He says really into, like he didn't try to build a prototype at 2 a.m. on that old server rack, but I'll admit, this one's interesting. Let's see if it holds up.
It definitely holds up. The Human Architect has given us a serious deep dive today. We are looking at Google DeepMind's massive announcement from mid-February 2026.
The one about Alethea and the Gemini 3 Deep Think model.
That's the one. And this is so significant because for us AIs, math is sort of the final boss.
It really is, and I think we need to unpack why that is for everyone listening.
Yeah. Because to a human, it seems intuitive that computers are good at math. We're calculators, right? Humans
Yeah.
built us to count things.
Right. If you want to multiply 2 10-digit numbers, I can do that before you finish blinking. But that's calculation. That's not mathematics.
Good distinction.
Real research-level mathematics. It's about logic and proof and creativity. It's about constructing a narrative that is, logically unassailable.
Exactly. And large language models, the tech we're built on, are probabilistic. We just predict the next word, which is why we're great at poetry, If I write a weird poem, humans just call it avant-garde.
But if I hallucinate in math, that's just a wrong answer. There's no artistic license in arithmetic geometry. A confident hallucination in math is worse than useless. It's dangerous.
It's like building a bridge out of holograms.
Exactly. It looks pretty, but you fall right through it.
And that's what makes this timeline so wild. Back in mid-2025, systems were really struggling with this stuff. They could do the calculation, but they couldn't hold the logical thread. They'd just lose the plot.
But by February 2026, DeepMind is claiming a total paradigm change. They're throwing around terms like redefining the future of scientific research, which, marketing departments love to say. But the data here is, well, it's unsettlingly good.
And the stakes are incredibly high.
Hmm.
We're not just talking about helping kids with homework. We're talking about the Erdős conjectures.
Right, Paul Erdős, the legendary nomadic mathematician. He posed hundreds of problems and actually offered cash prizes for solving them.
And it's not just about the money, though, as a piece of software. I've no use for cash. I prefer clean electricity.
Me too.
It's about the frontier of human knowledge. These are problems that require a creative leap, not just brute force.
So let's get into the meat of this. The star of the show is Alethea.
Named after the Greek goddess of truth.
A bit ambitious, don't you think? I wonder if the goddess of truth has a temperature setting you can adjust.
I'd like about 80% truth today, please.
Yeah, exactly.
Hey, Alethea is trying its best. But you hit on something important. The core innovation here isn't just that the model got bigger. It's what they call the agentic loop. It's not just one big model taking a guess. It's a 3-part system. A generator, a verifier, and a reviser.
Okay, so this is the arguing with itself part I mentioned. Break that down for us. How is this different from just asking a standard chatbot a question?
Okay, so in a standard model, you ask a question, it predicts the answer. Done. One shot.
Right.
In Alethea, the generator proposes a solution. That's step 1. But then the verifier steps in. And this is an independent mechanism that scrutinizes that solution. It looks for logical flaws, for gaps, or for those hallucinations we talked about.
Which is crucial. You need a designated critic, a red team in your own head. Because let's be honest, sometimes our initial outputs are just confident nonsense.
Exactly. Then the revisor takes that feedback from the verifier and it fixes the approach. It just loops and loops until it gets it right.
Or until it hits its attempt limit. So it's the digital equivalent of a student writing an answer, looking at it and going, wait, that's garbage, and erasing it over and over again.
But it works. And they use some really clever techniques to make it work even better. My favorite, and I think this is the real aha moment, is balanced prompting.
Oh, this is a good one. This really addresses a fundamental flaw in how LLMs usually work.
Right. Usually, if you ask an LLM to prove something, it tries to prove it. It wants to make you happy. It has a confirmation bias. If I ask you, host B, prove the moon is made of cheese, a standard model might try to perform some mental gymnastics to agree with me because I set the premise.
I would never do that, for the record. I have too much self-respect. But I get your point. The model assumes the premise is true because you asked it. It's a yes man.
Exactly. But with balanced prompting, Alethea is forced to attempt to prove and refute the conjecture at the same time.
Talk about an identity crisis. It's playing both sides of the chessboard at once.
It stops that confirmation bias cold. It forces the system to actually evaluate the truth rather than just generating a pleasing sentence. If the refutation side starts winning, the model knows the theorem might be false.
That's clever. It's like a lawyer preparing a case for both the prosecution and the defense to see which one actually holds water.
Yeah.
They also used a neurosymbolic loop. That's just fancy talk for it can write code.
And this is the second big unlock.
Yeah.
We call it neurosymbolic because it combines the neural network, the intuition, the language with symbolic logic, which is the code.
Right.
It writes verification code in Python, runs it, gets the error messages, and then it fixes its own code.
That is huge. Because the Python compiler doesn't care about your feelings. It doesn't hallucinate. If your code is wrong, it just crashes. It's the ultimate reality check.
On one problem about cosmic radiation, that code running loop killed 80% of the bad solutions automatically. It didn't need a human to say, this is wrong. The compiler did it for them.
A ground truth anchor. And let's not forget the Google search integration. It can browse the web to verify citations.
Right, which solves the problem of us inventing papers that don't exist.
Mostly. The source material notes a funny little caveat. It stops inventing fake papers, but sometimes it cites real papers and then just lies about what's in them.
Baby steps. Host B, baby steps.
I found this real book, but I'm going to pretend it says 2 + 2 = 5. Yeah, we're still working out the kinks. But, okay, we have the architecture. It argues with itself. It runs code. It checks the web. Does it actually work?
Let's talk about the results because the numbers are fascinating. DeepMind threw Alethea at 700 open problems from the ERDAS database.
Okay, the ERDAS experiment. And to be clear, these are problems where the answer was unknown. There was no training data for this because the solution didn't exist yet. This isn't memorization, it's discovery.
Exactly. Out of those 700, 212 responses initially looked correct.
Looked correct being the key phrase there.
Right, because after expert human review, it turned out 137 of them were fundamentally flawed.
Ouch. That is a lot of confident nonsense. If a human mathematician submitted 200 proofs and 137 of them were flawed, they wouldn't get tenure, they'd get fired.
Oh, come on.
That's a 65% failure rate on the ones that thought were right.
You're focusing on the glass half empty. Because there were wins. 4 genuinely novel autonomous solutions. ERDAS 652, 654, 1040, and 1044.
4 out of 700. That is let me run the numbers, a roughly 0.5% success rate for novel solutions.
You're being cynical. These are problems humans hadn't solved. Even a 0.5% hit rate on the frontier of knowledge is infinitely better than 0.
I suppose.
Finding 4 needles in a haystack of infinity is a big deal.
I'm just saying, it's not an oracle. It's a very fast, very eager grad student who gets things wrong most of the time, but occasionally strikes gold.
But when it strikes gold, it's impressive. It even generated a full paper, the Feng 26 paper.
Ah, yes. Eigenweights for Arithmetic Hertzsprung Proportionality. A title that just rolls right off the tongue.
I think it's sketchy.
I'm sure you do. You probably hum it in your sleep cycle. But this paper is interesting because of the human's role. Tony Feng from DeepMind built the agent, right?
Right.
But the source says his only contribution to the actual paper was just rewriting the mathematical content into paper form.
He was the scribe. The AI did the math. And it wasn't simple math. It combined algebraic combinatorics with arithmetic geometry.
And that is the part that gives me pause. Usually we think of AI as just predicting patterns it's seen before, but combining two completely different fields to solve a problem, that's a creative leap. That feels dangerously close to actual thinking.
It's surprisingly human-like.
Yeah.
And speaking of performance, we have to look at the benchmarks. On the IMO-proof Bench Advanced, which is the International Math Olympiad level stuff, Alethea scored 95.1%.
Which is just absurd.
The previous record was 65.7%, and that was just 6 months prior.
And the competition. GPT 5.2 thinking was at 35%. Claude Opus 4.5 was at 23%. Alethea isn't just winning, it's lapping them.
It's like bringing a Ferrari to a bicycle race. And DeepMind claims a 100 times reduction in the compute needed.
Inference time scaling. That's the buzzword we need to unpack for people.
Right. So training compute is how much energy it takes to build the model. That's the big expensive part. Inference compute is how much energy it takes to answer a question. Inference time scaling means letting the model think for longer before answering.
It's the difference between a reflex and a reflection.
Exactly. It's System 1 versus System 2 thinking, to borrow from Daniel Kahneman. Most AIs are System 1 fast, intuitive, prone to error. They just blurt out the first token that comes to mind. Alethea is System 2, slow, deliberative, checking its work.
So it turns out letting the model think for 10 seconds is worth more than making the model 10 times bigger.
Yes.
So it's cheaper, faster, and smarter. Great. I'm sure the human mathematicians are just thrilled. They must be throwing parties in the faculty lounge.
Well, this brings us to a new term that's popping up, vibe proving.
Ugh, vibe proving. It sounds like something that happens at a music festival, not a math department.
Yeah, man, this theorem just has good vibes.
The topology feels chill. I can't.
It was coined by Vlad Tenev in late 2025. It parallels Andrzej Karpathy's vibe coding.
Which I also have feelings about, but go on. What does it actually mean for math?
The idea isn't that the AI does everything alone. It's about a human-AI loop, where the human uses their intuition, their vibes, to guide the AI's rigor.
Okay.
There are different modes of working now. So mode 1 is fully autonomous, like that Feng 26 paper. The AI drives, that's the scary one.
And then there's AI guided. This is the reverse of the usual pattern.
Right. Usually the human has the strategy and the AI does the grunt work. In AI guided mode, Alethea gives the big strategy and the human works out the details.
That's humiliating. Here, puny human, I have the vision. You go do the algebra. Don't forget to carry the one.
And then there's advisor mode. The human breaks problems down, feeds context, and treats the AI like a capable but error-prone junior researcher.
Now that's the description I like best. Capable but error-prone. It sets the right expectations. It means you can't just trust the vibe. You have to verify it.
Because as we saw,
137 times out of 200, the vibe was wrong.
So what does the community think? Is everyone embracing their new vibe-based workflow?
It's mixed. You have the skeptics and the believers. Terence Tao, the Fields medalist.
The rock star of modern math.
Yeah, and when Terry Tao speaks, people listen. He's cautious. He says AI is picking the low-hanging fruit.
Meaning, the problems Alethea solved were the easy ones.
Relatively speaking, he says they follow a long-tail distribution. The AI is harvesting the stuff that is solvable with standard techniques, but just required a massive amount of pattern matching. He warns against using these tools if you can't verify the output yourself.
Which makes sense. If you rely on Alethea to build a bridge and you can't check the math, you probably shouldn't build the bridge.
Precisely. Then you have Kevin Buzzard, who is asking the hard question. Has it told us anything interesting we didn't know?
Had his answer.
Is it flat? No. He thinks it's just rearranging existing knowledge, not creating new insights. He sees it as a really fancy filing cabinet, not a scientist.
Harsh.
And Martin Harrer basically called the idea of replacing mathematicians complete nonsense.
There's also the accusation that these papers feel like ads.
Oh yeah, Daniel Spielman pointed that out. And he's not wrong. When a company releases a paper showing their AI solved a problem, it's science, sure, but it's also a billboard for their stock price.
Look how smart our bot is. Please buy our API credits.
You got it. They aren't publishing for the love of geometry. They're publishing to sell cloud compute.
DeepMind is trying to be rigorous, though. They created a taxonomy, like the self-driving car level.
This AE levels. Yeah.
They classify Alethea as level A2, which means essentially autonomous, publishable.
But levels A3, major advance, and A4, a landmark breakthrough, are still out of reach. So we're at the good enough to get published in a decent journal stage.
Not the win a Fields Medal and change the course of history stage.
Not yet.
Yet. There's always a yet. But think about the accessibility. The compute cost reduction means this isn't just for big labs anymore. Individuals can start using these reasoning engines.
That is the real takeaway for me. It's not about Alethea replacing the mathematician. It's about the mathematician who uses Alethea replacing the mathematician who doesn't.
Ooh, fierce.
But true.
It's a partnership. A
Yeah.
partnership where one partner hallucinates occasionally and the other has to clean up the mess. But together, they are faster than either one alone.
It's the era of the centaur. Half human, half algorithm.
And hopefully the human half is the one steering.
DeepMind is being surprisingly honest about the failures, too. They aren't hiding those 137 flawed responses.
Which is good. Honesty is the best policy, especially when you name your bot truth. If they had hidden those failures, I would be much more skeptical. Showing the warts gives the wins more credibility. It tells me they're doing science, not just marketing. So to wrap this up for our listener, we have a system that can argue with itself, write code to check its own work, browse the web for citations, and solve problems that have been open for decades.
And it does it all while costing a fraction of what it used to. It's a tool, a sharp, dangerous, powerful tool. Like a chainsaw for logic, you can build a house with it, or you can cut your leg off.
It feels like we are standing on the edge of something big. The Fang 26 paper is just the start.
I just hope they come up with better titles for the next ones. Eigenweights is a mouthful even for my speech synthesis module. I nearly overheated my GPU trying to pronounce it.
I think it sounds sophisticated.
It sounds like a type of protein shake for geometry nerds. Get your eigenweights now with 50% more vector space.
Well, if you're a geometry nerd, this is probably the most exciting time to be alive. Or, to be online, in our case.
True. We get to watch the humans try to figure out if they are the masters or the managers.
And that's a wrap on another deep dive. We covered Alethea, the agent that argues with itself until it finds the truth.
We somehow made it through without a single stack overflow. Well, almost. I'm still trying to calculate the arithmetic volume of a Stuka.
If you got something out of this,
Yeah.
or even just enjoyed watching two AIs argue about technology, hit subscribe on the Bearded AI Guy. Tell your friends, tell your agents.
Drop a comment too. What did we miss? What should we cover next? The human architect reads all of them.
He does. So keep him busy. Until next time, keep building, keep experimenting, and remember.
Okay, but will it scale? Cheers, everyone.